Hello, Count Sacke here, back with another video. Today, I welcome you to the first ever episode of Genshin Science Peer Review. This is a series dedicated to analyzing various forum posts, various Hoylab posts, maybe Reddit, and YouTube videos or anything science related and Genshin. The point is, I'll be reacting to these posts, and I'll be giving my thoughts and critiques, seeing how, whether or not they're accurate, or it's basically a reaction type content. I do a lot of things related to science and mathematics, so it never hurts to always take a look at what other people are doing and to maybe correct them if they're doing something wrong, or just give some comments about what they're doing. For our first episode, we'll be taking a look at something interesting I found in the KQM theory crafting library. I came across this one here, and it piqued my interest. The radius of Teyvat. You calculate gravity on the surface of Teyvat, the height of Celestia, and use it to find the radius of Teyvat. And it was written by Sacke eBoy69. Nice. What I also found particularly interesting is that this link, if you click on it, it will bring you to an overleaf paper. So this person really went hard on this, and well, I mean, you bothered to write a paper on it, so I might as well give my critique of it. And why not? There's also a picture of a frog here. So before we get started, I just want to quickly mention that I currently am working on a video for the physics behind Mabuika's motorcycle. I'm also in the process of trying to figure out how Linné and Lynette designed their magic trolley. There are a lot of different things I have in the works. If you find that stuff will be interesting for you, subscribe. That way you won't miss out on new uploads. I would also really appreciate it if you could like and share the video. Lastly, you can support the channel by becoming a channel member or through super thanks. With that, let's get started. Actually, I have one last thing I need to say, and this is very important. Do not send hate to this person. Do not send hate to Sexy eBoy69. Seriously, why would you send hate to Sexy eBoy69? Chilled. Even though my critiques might be serious, this paper is clearly a joke. This paper is meant to be a meme. It's all fun and giggles. With that, again, don't send hate. Be nice. Be nice. Okay, I trust you. First thing I want to point out is that even though it says January 12th, 2025, this is not the date it actually is written. There's no date, so it kind of just defaults to whatever day you're looking at this document, and I just happen to be looking it on the 12th of January 2025. Let's start rating. So the abstract is Math Go Burr. Obviously in an abstract, you actually want to include the basic idea of what the paper is. You kind of summarize the entire paper in 200 to 300 words. That's typically what it is. Unfortunately, this person did not put an abstract, so we don't really have a summary, so that's unfortunate, but oh well. Again, this is a meme. Don't take it too seriously. Then we have the introduction. In the introduction, we basically have, well, these are basically a set of objectives. You calculate gravity on the surface of Teyvat, the height of Celestia, and use it to find the radius of Teyvat. I will say that this introduction is rather lacking. What exactly do I mean by that? Well, if you actually take a look at a real, if you take a look at the actual, an actual introduction, typically you'll have something called the background of the study. This basically provides history of how on Earth, or just basic idea, leading up to this paper, the history of it. And well, after that, we typically have something called the statement of the problem. In actual research, we tend to focus on innovation and problem solving, so that's why we have a statement of the problem, because in order to innovate or to solve problems, there has to be a problem in the first place. The point is, this statement of the problem is to make it explicit on what exactly the problem is. What is it that this paper wants to take a look at, and what kind of issues it wants to solve. And of course, after that, you have objectives. This is what they put in their introduction. They have 3 objectives: to calculate the gravity, the height of Celestia, and the radius of Teyvat. But we don't really get any context behind those objectives. Usually after that, we have significance of the study. Again, since a lot of research papers and whatnot tend to be so focused on progression and innovation, usually you also want to make it explicit as to why people should care. What is it that your paper is doing differently from others? That is what the significance of the study is. But after that, you typically have something called the scope and limitations. This is very important. Obviously, you cannot cover everything. You can't cover all of the universe that exists. So you have to tell the audience, what is it that you're focusing on? What is it that you're not going to consider? What is it that is outside of your scope? Otherwise, people can kind of criticize you for stuff that you aren't even going to consider. Like, somebody could say, calculate gravity on the surface of Teyvat, but did you consider the terminal velocity of the player? Chill. We don't need to consider the surface. If you don't really need to consider that, we don't need to worry about it. Okay. So scope and limitations basically gives an idea of what you're not going to be focusing on and what you are going to be focusing on specifically. It's more easy to say what specifically you're focusing on. And just any other clarifications regarding that. So out of these 5 things, I would say the most important are the objectives and the scope. There are only objectives here. That's a bit of an issue. Would be nice to have given maybe some idea of what your scope was, but whatever. This is a meme paper, so I guess it works. So yeah. Anyway, next we have is finding gravity. We'll use basic kinematics to find the value of the gravitational acceleration, namely this equation. That equation, it comes from kinematics. I talk about this a lot, in which case you have that delta y is equal to gt squared divided by 2 plus viy t. And Sexy E-Boy, he ended up ignoring this initial vertical velocity, so that is what it is. And yeah, basic algebra, you do this. Or G, and congratulations, good job on explaining what the terms in the equation are. So G is gravitational acceleration, Y is displacement, T is time. Good. Therefore, to find the gravity, we must measure displacement and time taken. Yep. We conduct these tests by using a reference height to find the height of a brick in Mondstadt. Then we will jump using a character. Using frame counting, okay. This little jumping thing makes me a little iffy because something to note about jumping is that the initial vertical velocity is not 0 for a jump. When you jump, well, you have to somehow be moving at the start, in which case you'll have an initial vertical velocity, and then, you'll go up until you reach some maximum height, and then you'll fall down again. But your velocity at this point is going to be 0, but your velocity here is going to be an initial velocity. So that it's a little concerning that you didn't include that, but oh well. Alternatively, in basic kinematics, in basic kinematics, if you consider the time it takes to go up and the time it takes to go down, they're exactly equal, assuming that the height is exactly the same. That is just a little bit of a concern, but who knows. Okay, so for finding the displacement, they said they will use Zhongli as their meter stick or their unit of reference for distance. In which case they say, okay, so Zhongli is 185.4 centimeters tall. And they seem to get it from, okay, so it's from this website. We go to this website, let's see, Zhongli. Okay, so yeah, they basically got it on here. I'm not too sure if the player's height or the character heights are accurate to what the scale is in game. That is a bit of a problem. I don't know if 185.4 centimeters is how tall Zhongli is in game. So that could be a source of error. Alright, so using sophisticated software, MS Paint, we find that Zhongli is about 5.72 bricks tall. And then each brick is 32.41 centimeters tall. I don't know why you... I'm sorry, I'm gonna look at your code here. Zhongli is... Why did you put the tall into your $sign? Okay, I'm just gonna say here, you could have just done this. You could have done like $, 32.41 centimeters, and just do tall. But if you really wanted to keep it inside the $sign, what you do is you put a slash. You put a slash here. That way, it will put a space in latex. That I'm just saying, because in this one, there's no space there, as you can see. You can put the slash if you wanted to put it inside, and even then, I don't know why you don't just do something like this, or even just this is fine. Well, up to you. Maybe you just wanted to do... Oh, okay. Maybe you wanted to do italicize, in which case there's something called text italicize, 32.41 centimeters tall. You could have just done this. You could have just put this code and have it there. And if you wanted to have it italicized, well, you can also do boldface. There's also this, BF for boldface. So yeah, just some latex code hints. Basically, all you do, take this, divide by that, you'll basically get the number of centimeters per brick. Okay, so we have a unit of measurements for the number of bricks. That's fine, everything's fine so far. Again, the only iffy thing is that whether or not this is actually correct in-game, that's another problem. That's a problem that I'm not too sure. It could make this whole thing... it might invalidate the numbers or the results of this whole thing. Alright, so it seems like they've done 10 trials, and they've... approximating the amount of bricks beneath Zhongli at the apex of his jump. Okay, so that's what this is measuring, the number of bricks high Zhongli jumps. And he also seems to have some evidence. Let me just copy that. Also, mute. Oh, he can jump. And, well, yeah, you can basically... Okay, I'm not too sure. Are they basing it off of, like, this foot here? That is something I'm not too sure. Is it, like, in the middle? Is it, like, up here? I don't know. I do feel like a good place to use a reference would be the vision. If you consider where the vision is, in which case it looks to be approximately in line with this line of bricks, and then you can jump and you can see how high up. Okay, so then you can count the bricks and figure out, yeah, how high up the vision is. I think that's a better way to do it, because I'm not too sure if you're using like this lower foot or this upper foot. It would have been nice that if you were to explain a bit more in detail about the methodology. I spend a lot of time in my videos talking about methodology. I want people to know where exactly I'm coming from. And under methodology, you have materials. You also have a setup, could be like the location. In this case, you do explain that, hey, we're in Mondstadt. So that's set up. We also have Zhongli. It's kind of weird to say a material, but Zhongli is essentially the meter stick, so it is what it is. And of course, you also should have procedure. Procedure. Very important stuff. You have to have all of them. Procedure, put it into a list. Like step 1, step 2, step 3, step 4, and so on. Put it into a list for procedure. In this case, you're not really, you're just explaining it. But it would be nice to have it into a list format, because, lists are pretty easy to read and whatnot. In which case, if you're going to do that in LaTeX, what you should do is begin something like enumerate, and then you got end, and enumerate, something like this, and then you have /item, and then you put step 1 jump or something, and then you'll have item. What this will essentially look like is like you have step 1 jump, step 2. This could be, or maybe it could actually be more like start recording. What it will look like is something like this: start recording, then jump, step 3. You get the point. Something like that. Converting it into centimeters. From the table above, we can calculate that the average displacement in bricks is 3.360. Okay, so that's fine. Then we have finding time, in which case they say they have an assumption. Would be nice to put that into the introduction if you're talking about assumptions. Yeah. The in-game Teyvatian clock is universal, so the speed of causality in this universe is unbounded and infinite. What is this? Whatever the heck Al-Haytham was reading? I actually understand what it means, though. The author doesn't understand what it means, but someone said to put it in. I am on your side. Speed of causality and universal clock. Okay. This might sound crazy, but essentially because of special relativity and general relativity, time can flow differently. Two people can have different rates of time. And this is proven experimentally. It has been proven experimentally to exist. There was this experiment where they had someone on the ground. They had their own clock. They had their own stopwatch or something, a clock, and they had someone in like a fighter, in like some fighter jet. I can draw. Whatever. They had someone in like a jet, and they also had their own clock inside of that jet. Basically, this fighter jet, this jet went around and around for a while, and when they actually finished the experiment, they found that the guy, we'll call it A and we'll call this one B, they found that the time on A was greater than the time on B. So yeah, this is real stuff. And that's actually called time dilation, and it's something in special relativity. It's a really complicated topic. But okay, what's up with that whole speed of causality and the universal? Universal clock just basically means that it doesn't matter how fast you're moving or where you are, the amount of time passed is exactly the same. So you could be flying in this jet, but when you come back and get out of that plane, you two will have an equal time. Assuming that everybody starts their clock at exactly the same moment, and it doesn't matter where you are or how fast you're moving, you will all always measure the same amount of elapsed time. That is what that is. That's what the universal clock means. And the speed of causality in this universe is unbounded and infinite. That one is a bit harder to explain, but as a consequence of time dilation and special relativity, the speed of causality is limited by the speed of light in a vacuum. And if you don't know, the speed of light in a vacuum is exactly 299,792, 458 meters per second. Basically, if we have two locations or whatever, we have two objects or whatever, if you send a signal to that from A to B, if you send a signal, that signal cannot move faster than light. So if it takes light 2 seconds to get from A to B, any signal, whatever it may be, cannot get to B faster than 2 seconds. It has to be longer than 2 seconds, or exactly 2 seconds. The speed of causality being limited basically puts a limit on how quickly two objects can communicate. And if you were to go faster than the speed of causality, you could get time paradoxes. Like, for example, like maybe you sent a message at exactly 1 o'clock. Maybe you'll send a message at 1 o'clock. If the speed of causality was like faster than the speed of light, it would be possible for B to send a message back to A maybe at like we'll say this is like 1 p.m. You could send a message back at maybe like 12:50. You could send the message, receive a message before A even sent the message in the first place. You get time paradoxes essentially. Because of this speed limit, so you could have like a camera pointed at like something. Maybe let me draw in relatively okay camera. So we have a camera, we have a person over here or something. Whatever this distance is, there is a delay between, it has to, because light has to go to the object and reflect back to the camera, or whatever, light has to bounce off of the person. There is a delay between what is actually happening here and what is being recorded here. There is a delay. So yeah, that is just how it is. But with an infinite speed of causality, what will happen is that these two, whatever is being recorded, that is the exact same thing that is happening here. So that's what infinite speed of causality does. There are videos that can explain what happens when you exceed the speed of causality, or specifically the speed of light. There are great videos about that, so you can look it up on your own time. Okay, so yeah, we can find time by frame, counting our 30 frames per second recording of jumps. Every frame is, yep. And each second is 1 minute on Teyvat. Okay, that's interesting. Okay. I'll just keep reading. Trial uses for each jump. Is that the same link? Yeah. From the table above, we can calculate the average time in frames is 7.6. Converting that to Teyvat seconds, you get a time of this. That is a weird. Okay, these numbers are getting a little weird. And okay, but I'll keep reading. By plugging in the values obtained from section, yeah, we obtain 2. Oh, this equation 2. Okay, equation 2. We obtain G is equal to this. That is really tiny. Hold on, what? Because okay, I have a whole series where I calculated gravity, so that's really weird. And I must point out that I calculated gravity with very high precision, might I add, very high accuracy. I calculated 20.4 meters per second squared, so that's kind of weird. But maybe it might have to do something with this whole Teyvat seconds going on here. Each second is 1 minute on Teyvat. Is that, first of all, I want to check that. So maybe it's like he's using the in-game count time. Let's see. So here's Genshin Wiki. Get out of here, ads. Get out of your ads. We have that. Okay, so the cycle repeats every 24 minutes. So, okay, let me go ahead and double check this conversion. So we have that real life minutes, which I'll just indicate as this. So 24 minutes. Then we have 24 minutes for every 1 day in Teyvat. Teyvat uses a 24-hour cycle, so we know that that for every Teyvat day, there are also 24 Teyvat hours, and then for every Teyvat hour, there are 3,600 Teyvat seconds. And then maybe what we can do is also convert this. So we also, for every minute, there are 60 seconds. In which case, okay, we can cancel out this minute, we can cancel out this hour. The 60 reduces this thing to 60. So we know that this is essentially saying that for every real life second, there are 60 Teyvat seconds. Or in other words, you're basically saying that 1 second is equal to 1 Teyvat minute. But I want to point out that this is specifically from gameplay, not necessarily lore-wise. I do think it's a little weird to use this unit of measurement because it's like, I don't know, it just feels weird. I just feel like that from a lore standpoint, 1 second for us being 1 minute for Teyvat feels really off. And especially when you consider this gravitational acceleration, that is really weak. For reference, the gravitational acceleration of Earth on the surface of the Earth is approximately 9.81 meters per second squared. 9.81. This is 0.009. I don't really know why they converted it. In fact, I guess it makes sense, the most sense from a gameplay perspective, but I mean, when you watch, but if this was really true, and we played it out, Teyvat would be moving so slow. Like, things would be moving in such a slow motion.
Watch out!
The slow motion is just, it's not even funny. It's like so slow. I don't think that sounds right. I mean, when we look at the game, when we play the actual game, everything looks pretty normal. So when I did my calculations, I always just use the actual real life time that we measure the number of frames. And then again, this is their choice. But something I want to do, I'm just gonna, maybe just to be fair, I'm going to convert my measured 20.4 meters per second squared and convert that into meters and Teyvat seconds and see what we get. This is measured directly from the game, so these meters are measured directly from the game, so we're considering game meters. And this one is real life seconds, so maybe that feels a little weird, but again, it's what we have. So we have 1 second, real life second is 60 Teyvat seconds, so 1 real life second, 60 Teyvat seconds. But we also need to convert twice because we have the squared, so go 60 like this. And this should be equal to 0.00567 meters per Teyvat second squared. Why is your gravitational acceleration is really high. What? Or this the gravitational acceleration in this is really high. Let me convert that to the other way around. So we got 3.948. Wow, that is a really high gravitational acceleration. What? There is no way that is not what, because again, I measured gravity and it was very accurate. Something is wrong. Something's wrong here. I measured this with very high accuracy, so to see that the number here is 33.948, something's weird. I don't exactly know where things might have gone wrong. I'm tempted to say that it might have something to do with this, but I don't know. For all I know, this could be accurate. And after all, in one of my videos where I the measuring distances on the map video, I talked about how someone used Razor's height to measure distances, and it seemed to be pretty accurate. At least that's what they claimed. I didn't actually bother to check it. Maybe I should probably check their claim on how accurate it is. Just saying, I'm not sure if that assumption is true, but I'm going to assume that it is true, that it is pretty close or pretty accurate to what it is in the actual game. If that's the case, this is the gravitational acceleration for falling. But if this is correct, assuming that this is correct, then this means that there are different physics for when the player is going up or jumping upward. I did plan on considering the physics of jumping in Genshin Impact. I do plan on making a video on that. It's just something that's going on the side. Whatever the case is, I'm not too sure about how accurate that value is. This gravitational acceleration, and they talk about error and they just say astronomical. Would be nice to explain a bit more where the error comes from. From what I see, there's nothing particularly wrong with any of the methods that this person has done. It's more of this, like, this one is a little iffy, and I do think that the choice of Teyvat seconds for the units is a little silly and strange, but okay, sure. 20.4 is large. Granted, it's like more than twice the gravitational acceleration of Teyvat, but at least it makes sense in the sense that stuff wouldn't go flying off into space with how weak this is. It also is worth mentioning that if this is really true that it's like that low, these people got weak legs, my gosh. Seriously, these people will have like some of the weakest legs because they will not be, because if you have this low gravitational acceleration, you could jump pretty high. You would be able to jump very high. Yeah, I don't know. I do find this choice of units to use the in-game time as seconds is weird. But again, it doesn't necessarily stop. You could still work with this, and it will still be accurate. It's just that the units are weird. It's like working with inches versus meters or centimeters. Whatever. What the heck is an inch? An inch is 25.4 millimeters. Whatever. It is what it is. I don't really particularly see anything wrong with this. A source of error could be like this 30 frames per second. If you have a higher frame rate, it would reduce the error. So that's a bit that can cause some inaccuracies. But I do think that this number is. I do believe that this is still probably pretty close, relatively close to what we actually should be measuring. So I don't know why it's different. It is what it is. All right. I still have like an hour of footage left to go through. So if I'm being completely honest, I think it's best if I split this one up into 2 parts. And I'm trying not to make videos that long. We should have the option to rest. So I think 30 minutes is about a good place to stop. And even then, I'm trying to keep my videos like 20 to 30 minutes. I do personally think that 40 minutes can be a bit long, especially when you consider like there are a lot of things you can do in 40 minutes. It just so happens that a lot of my recent videos are becoming 40 minutes. I swear, I'm trying not to do that. It just so happens to be how long it is in script. I just do voiceover and then it's like, oh, that's 40 minutes. Okay. Well, I hope you're not too bothered by this. After all, you can always watch them back to back. If anything, I'll have the next part ready soon, so you don't have to wait too long. So yeah, once again, you can support me by subscribing, liking the video, sharing it, becoming a channel member, or by super thanks. By the way, also let me know what you think of this new series idea. If you ever have any ideas or you come across any posts yourself that are pertaining to math and physics and Genshin, don't hesitate to send it into the comments or just message me or somehow, maybe through Discord or something. So yeah, you can just always send it to me or something and I'll take a look. With that, thanks for watching and hope you've enjoyed.